All right, so today we're going to go over the distance formula. This one's a little tricky. We last class talked about how to find the distance between 2 points if they're in a straight line. This one's a little harder because it's a diagonal line. The formula is this. So if you just look at this formula, it's really confusing. And I think trying to memorize it can be annoying. But if you understand where all these numbers come from, it actually makes a lot of sense. You don't really have to memorize anything because it just makes sense from something you already have memorized. Let's look at this one, okay? It started here and it moved 3 to the right and it went up 4, okay? It went from here to here. I'm going to draw a shape using that line. Hopefully you can see right angle triangle. In our right angle triangle, this is the hypotenuse and these are the 2 legs, okay? I'm going to label the information I know. I know that this side length is 3. It's pretty easy to see on my graph that it's 3. And then here on this side, I know it's 4. Again, it's pretty easy to see on this graph. Now I have a hypotenuse. I don't know how long it is. But you know how to find how long a hypotenuse is. Use Pythagorean. A squared plus b squared equals c squared. Remember, this is always the hypotenuse, the c squared, the one across from the right angle, the one we're always going to care about when we do diagonal lines. So I'm going to put the numbers in. 3 squared plus 4 squared equals c squared. Well, let's cut h squared, whatever, same thing. Okay, so this is 9 plus 16 equals h squared. 25 equals h squared. Now we can square root both sides, and I get h is equal to plus minus 5. But again, can you have a negative length of a line? No. So I'm going to say, nope, it's just plus 5. So the length of this line is 5. I know that because I just calculated it. All we did was draw Pythagorean so we could see it and do it. Let's do one more, okay, over here, where it's a little bit harder. So I'm going to draw my Pythagorean again. That's my right angle triangle. You could draw it this way. It doesn't make a difference. So I'm going to do it this way because I like having it so I can write on the sides instead of the top. Now let's do the distance. Again, if this was just 2, okay, because I'm telling from the graph, that would work. But let's use the formula we talked about last class. We're going to take this point and subtract this point. So these are x values. So I'm going to call this x2 and this is x1. The first point, the second point. So that x1 is, we said x2 minus x1. So that was -4 minus -6 gives me 2. That's how I found the distance of the bottom part. Then, to find this distance, we do again, this is y2, the y of the taller point, and then y1, the y of the bottom point. So y2 minus y1. So we're going to do that. It's 4 minus -3, and that gives me 7. So if I wrote those numbers in there, that would be 2, that would be 7. And if I wanted to find my Pythagorean, which we'll call h, the formula again is h squared is equal to a squared plus b squared. This one's a, this one's b. So this would be h squared is equal to 2 squared plus 7 squared. H squared is equal to, that's 4 and that's 49, so 53. So h would be equal to square root 53. I'm just going to leave it like that. I can make it a mixed radical or whatever, but same thing, okay? That's simplified. If you wanted to do decimal, you'd have to round. This is more exact. So let's take what we know and write a full formula. So we're saying h squared is equal to a squared plus b squared. That's Pythagorean. That's what we're doing. If I want a squared, that was, we said, the bottom, the x's. So to make the x's, we needed to do x2 minus x1. So I just took this information that we already had. That's what we said before, and I just put it right here. Now I'm going to say plus, and the b squared was this one, which we said was with the y values. So that one was y2 minus y1, squared again, because it would be squared, okay, equals h squared. Now, if I don't want to have a squared, we had to square root it, right? To get rid of it, we had to square root both sides. So really, it's square rooted like that. Now, if we look over here, what we just created is the exact same as the complicated formula I gave us at the start. That's where this comes from. So if we look at this formula really quick, we square rooted because of Pythagorean, right? H squared equals a squared plus b squared. So we had to square root both sides. This was the horizontal width, okay, which was when we did the 2 points and subtracted them so we could find the distance. And then this was the vertical height, which again, we did by doing the y2 minus the y1. this was x2 minus x1. We had to do the squareds because, again, in Pythagorean, it's c squared equals a squared plus b squared. Those are the squareds that we had. So I do not think that you should memorize this formula. I think that if you're given a graph, you should figure out the numbers and just do Pythagorean like you normally would. If you're given just points, okay, so sometimes the question will be like, oh, these are the 2 points. Okay, what's the distance between them? It really helps just to super quick sketch a graph. So I'm like, oh, 2, 2, 5, 10. Okay, cool. And I do this, and you have Pythagorean. I don't see why you wouldn't draw a diagram to help you with this kind of question, just to help visualize it. You can be maybe 5 seconds faster if you don't, but I think it's worth it because having a diagram helps so much. Okay, so that's basically it. Use Pythagorean, which you already know, and you're able to solve for the distance of a diagonal line.